good. So we have talked about dealing with expressions that have rational exponents, nth roots, simplifying radicals, rationalizing denominators, but they all had numbers in them, right? They just had numbers. There were no variables. So let's ratchet up a notch, just like we always do in Algebra 2. Put some variables in there, okay? So everything's going to work the same way, but it's just going to be more general because you have variables in there that we have to simplify, okay? Also, you got to keep in mind the sign of your answer. Well, your book simplifies this a little bit because this is what they say. In general, this is the rule, okay? When your nth root is an odd nth root, you don't have to worry about any signs, because whatever sign went in is the same sign that comes out. So the rule is the nth root of x to the n, they're inverses, they cancel each other out, you get x back, okay? So it doesn't matter if it's the 7th root of 5 to the 7th or 7th root of negative 5 to the 7, you're just going to get your whatever original input back, okay, because they're inverses. Now, when it's an even power, they're also inverses, but there's kind of a domain issue, right? The odd ones, the even ones, there's a domain issue. So on this, whenever you have, say, a square root and x squared, they do cancel each other out, giving you the original input, but you have to make sure it's the absolute value of that. Take a look at the two examples over here. So the 4th root of 3 to the 4th, those should cancel each other out and give me just 3. However, the 4th root of negative 3 to the 4th is also 3. It doesn't give you negative 3 back. It only gives you positive 3. And the reason why is because I have negative 3 raised to the 4th. Negative 3 raised to the 4th, it's an even number. I should get an even number out of it. Or, positive? Positive. I should get a positive number, not necessarily even. Whoa, what's going on here? Yeah, you should get a positive number out. So your book makes it simple and says, hey, make all the variables positive. Don't even have to worry about it. Okay, so simplify these expressions and assume all the variables are positive. Okay, so I want to take the 5th root, basically, of this whole expression. And this is just an application of the power property, where everything on the inside here gets that 1/5 power. So that's 32 1/5 power, and 5 to the 5/5 power, because you multiply them, and then in 30/5 power. And now simplify all that. The 5th root, basically, of 32 is 2. Whoa. Let's back this up here. Let's back this up. That shouldn't have been a 5. That should have been an m. Anyway, 5 over 5 as an exponent, that's just 1. And then n, just divide the exponents out, and I get n to the 6th. And then that one's done. Okay. So this will proceed in a similar fashion. So this 625, I've got to take the 4th root of 625. 4th root of 625 is 5, because 5 squared is 25. 25 times 25 is that 625. Now, what about this z thing? Let me just write this over here. Let's think of it as z to the 12th, and that's to the 1/4 power, and then you would multiply those exponents. That's z to the 12/4 power, which is z cubed, and that's the answer. The short way to think of that is take this exponent that's on the inside and divide it by the exponent that's on the outside. Just divide it. And I get z to the 3rd power. So that's what this next slide will say here. When dealing with variables inside the radicals, just divide the power that's on the inside, by the index, the little number that's on the outside of the root. Okay? So there's two little things that go along with that, and that's the first one is the quotient of that power. That's what's going to get to come out. It gets to come out of the radical, but the remainder, whatever is left over after you divide, that power has to stay on the inside. Let's see what I mean by that on this example right here. I've got the 5th root of x to the 6th, y to the 12th, z to the 3rd. Okay, so I'm just going to divide that 5, first of all, into that 6. Well, it only goes in one time. only goes in one time, so I'm going to have an x to the first power on the outside. What's the remainder after you divide by 5? It's a remainder of 1, so that's why I have x to the first power on the inside of that. Okay, now let's do the y. I'd take that 12, take the 12 and divide it by 5. How many times does it go in there? It goes in there twice. That would be 10, which makes 2 left over. The remainder power has to stay on the inside, so y squared. Okay, and then if I try to divide the 3 by the 5, it doesn't go in there at all, so I just leave the third power on the inside. That's what you do. That's a general technique. Divide the powers. Quotient goes on the outside. Remainder stays on the inside. Okay, so let's try it with these two problems. So without even having to break this up or think of it as like a rational exponent or anything, I would just take this 6 divided by this 6 and it just goes in there one time, so that's just r. Those are inverses of each other, and since it's positive I don't have to put absolute value around it. Okay, and then 18 divided by 6 gives me s to the third power, and then that one's done. Okay, over here on number 4, the 56 divided by 7, I just go ahead and divide that and I get 8. Now just subtract your exponents with the like bases. So I have a to the first minus a to the 5/6. That gives me a to the negative 1/6 power. The b, there's nothing to combine it with, so that's b to the 3/4 power. And then the c is negative power, so I'm going to flip that back up to the top and make that c to the positive 3 power. So the only thing left to do, wait a minute, was that negative 1/5? So it's 1 minus 5/6. That should be a positive 1/6. What? What? Okay, let me fix that. Let's pretend like that didn't even ever happen. Alright, so notice that all these exponents are positive, so they get to stay exactly like that, and there's nothing else to do on it. So be careful, apparently, on your subtraction. Anyway, so that concludes that one. Let's see what we have next. Here are 2 of them for you to try on your own. So give that a try, shall you? Alright, and you're back. We're almost done here. So here are the 2 answers. On number 1 here with the index of 3, first of all, taking that 6. 6 is just 2 times 3. There's no 3 factors of anything, so it stays on the inside. And then x to the 4th, divide that by 3. It goes in one time, so you have 1 power of x that goes on the outside. And a remainder of 1, so 1 power of x stays on the inside. Okay, taking the y to the 9th, 9 divided by 3 goes in evenly 3 times, so you just get y to the 3rd on the outside, nothing on the inside for y's. And then z, it's 14. 14 divided by 3, it goes in there 4 times. 4 times would make 12. And that leaves 2 left over that have to stay on the inside. Okay, over here on number 2, I wonder if you kept going. I wonder if you rationalized the denominator. Did you notice you were supposed to do that? So across the top, whenever you break up these radicals, 8 divided by 7, it goes in there one time with a remainder of 1. So 1p goes on the outside, 1p on the inside, and then there's nothing to simplify on the bottom. But you can't leave that 7th root of p to the 5th, q to the 5th on the bottom, so you have to rationalize it. Subtract that from 1, remember? I've got 5/7, so I'm going to need 2/7 in order to get rid of it. So multiply 7th root of q squared on the top and the bottom, and that's what you get at the very, very end. Okay, so one more problem, well, one more exercise that comes in 2 parts, and then we'll just end it there. Okay. So again, just some operations. Assume all of these variables are positive, just for simplicity's sake. This one, very, very simple, because look, that is the same as this. It's essentially like terms. So just add up your like terms and you get 23 of these things. 23, a to the 4th, b to the 2/3. And you don't do anything else with it. That's it. It's done. Okay. So looking at number 2, doesn't look like you can do much to it because you don't have like radicals since we're subtracting them here. But you got to simplify what's on the inside there. Oh, and that's 7. What about that fourth root of x to the 7th. I guess we got to simplify that too. So the 10 on that one's going to come down. When I divide the 4 into the 7, it goes in there just once. So I have x on the outside, and that's going to leave a remainder of 3 on the inside. So fourth root of 5x cubed. So that's the simplified version of that first piece. Okay, now let's take 80 and simplify the 80. So 8 and 10, that's 2 and 5, 2 and a 4, and a 2 and a 2. So what is this, fourth root? Oh, look at that. I've got 1, 2, 3, 4 of those things. So that 2 gets to come out. So minus 2x. And the x cubed has to stay on the inside because, well, there's it's not bigger than 4. Fourth root of 5x cubed. Oh, and look at that. They're like terms now. So I have 10x of them, subtract away 2x of them, I get left with 8x of them. Fourth root of 5x cubed. And that concludes our lesson on rational exponents, nth roots, and properties, and simplifying all of these things by hand. And you have that guy right there, Isaac Newton, of course, to thank for all the little notation on the fraction-y exponents and stuff. It's all his fault. So here's your assignment. You do have one worksheet to come prepared to class with, and see you in class.